A very warm welcome to today's expert webinar on vector database. I'm Ankita from SpringPeople. We are India's largest enterprise training provider. I will be your moderator for today's session. Today we are honored to have Mr. Rajeev Chandran, a visionary leader with nearly 2 decades of industry experience, with expertise spanning data engineering, ML engineering, search, cloud, and DevOps. He has played a pivotal role in building high-performance, scalable solutions across e-commerce, retail, search, and advertisement industries. In this session, Mr. Chandran will explain vector databases and their role in handling complex data like images and text embeddings. Now, without further delay, let's begin. Over to you, Mr. Rajeev.
Thank you, Ankita. Extending a warm welcome to all for this seminar on vector databases. Okay, so in this session today, we would look at vector databases from the perspective of what it is, its architecture, the use cases, the different variants of vector databases, and how it's become, from being one of the most used databases in the whole space of AI and ML. So without much ado, let's start. Okay, so now it's all about managing the data and the different types of data and how you're going to organize it, right? So that's why you need a database. And if you look at your file system that you use day in and day out, that's also a kind of store where you organize your files. So much like that, if you want to organize this for quick retrieval and for read and write with much better speed and things like that, you need different kinds of data structures. So and again, you need it for different kinds of types of data. As you are maybe aware that there are these 3 large classes or categorization of data: structured and unstructured and semi-structured. The unstructured and semi-structured kind of look alike, just that the way they are organized within themselves slightly makes that a kind of a difference. Okay, so today the data are either human generated, much like it could be anything, maybe writing it on a piece of paper to writing it in any of the electronic digital devices. So either it is a human created or today extensively machine created data. So either of them can create any of these kind of data, whether it's a structured, unstructured, or semi-structured. Okay, so as I said, the whole idea of having databases is to organize your data in such a way that it can be retrieved quickly, retrieved, or written to in the shortest possible time in whatever function that you are kind of doing. So largely, today's if you look at the large aspect of today's databases, they are either OLTP or OLAP databases. And when I say OLTP databases, these are the transactional databases where you need real-time accessing. That is, or another way to look at it is when you have databases, when you have transactions which involve CRUD operations: create, read, update, delete, and a database is tuned for that, then we call them an OLTP database. On the other hand, if you have databases that are performance tuned for or built, a purpose built for, let's say, joins and aggregation and roll up, etc. Now these are databases which are designed then for analytical operation. So largely the databases fall into these, and they could be based on the protocols or the principles they follow. It that they could be a single or vertically scaling database or a horizontally scaling database. So it could be one of it. However, even though you have such kind of databases and they are being efficient in terms of handling different kinds of data uh, in, in, in the present world, what it does not able to do is when it is presented with unstructured data, neither of these databases are able to organize it. And when I say organize it, in the sense I'm it's difficult for it to be, you can't read it, you can't store it in the way in the way you do it with your structured or semi-structured database. So that is the challenge. That's the challenge that traditional databases pose here. And when I'm using the word OLTP and OLAP, it also means that they could be relational, or they could be NoSQL, or they could be even relational, which is horizontally scaling. So all of these databases still handle both the largely structured and the semi-structured data, but they are never designed to handle your unstructured data. Okay, so taking that forward, uh, you have this database called a vector database. So it's changing the way you are going to actually work with the data. Now, what is a vector database? Now, vector database is, though initially designed to handle unstructured data, and when I say an unstructured data, it can be an image, an audio, video, or a document, uh, uh, and all these are of course organized in your file system. But if you have to make do a query on these database, like example, let's say you have an image, and it could be a scenic image, and then I want to query on that image, much like how you do a query on your SQL databases and things like that. Yet on this image, I want to query and check, does this image have a mountain, or can the image, is the image having any people, or does the image have any vehicles? Now, that's not something any of the query languages or the database themselves can handle. Now, this is what our vector databases are able to do. They are specialized to handle these unstructured data. And when I say specialized to handle, that means they help you to store the data in such a way it can be retrieved quickly. It is organized in a way as a structured database has some structure. The vector databases have some structure, but that is not similar to like a table format, but it is organized in a different way. So that is what vector databases are solving. It is solving this problem of helping you to store, organize, retrieve, and maybe making changes as well to data that is not possible in the traditional tabular format. Okay, so now just doing a comparison, you are pretty much aware of your traditional databases. They are organized in rows and columns, whether structured or semi-structured. They are still organized in rows and columns, whether it is relational or NoSQL. They are still, there is some kind of a tabular format. When if it's total, it's a pure structured database, the tabular format is in a highly constrained way. Whereas if it's a NoSQL kind of thing, where the structure is a little more loosely connected, and they are optimized for some kind of transaction, either whether it's a real-time transaction, or it could be for some kind of analytical transactions. And what is important about these traditional databases is in this idea of their search needs exact matching. Now that's very important. You will not be able to do approximate searching, right? Approximate matches, rather, I should say, are not handled by traditional database. They are very deterministic in nature, can't handle probabilistic side of it. On the other hand, vector, the structure in this vector is more like a multi-dimensional matrix. I'm sure you know what's a matrix. It's stored as a multi-dimensional matrix, and the important part in this is I am able to do search, approximate or probabilistic search can be done. Right, I do not have to be they need not be deterministic criteria here. That makes that big difference when you compare it, and hence you would find that it's used very well across your AI, Gen AI architectures, and traditional transactions continue to do it. Be it on the finance space, you have your relational, and if it is on your general other platforms like your LinkedIn's and Facebooks, they have their own way of organizing to NoSQL. So that's that's the way you contrast it. Okay, so pretty much you understand why we need a vector database. The vector database is needed to help organize, manage, retrieve, search data. When I say data, it's the contents, probably inside an image, inside a video, inside an audio, inside a PDF document or a Word document. And then you would want to search in a way. The other side of it is I'm able to search across different different kinds of unstructured data and bring in a similarity. Right, so we pretty much know why the vector databases is needed to handle these kind of things. Okay. So how does a vector database work? So vector database works using this idea of embedding. So now how does this work? I was just talking about how you store data. In the traditional databases, be it relational or NoSQL, the data is collected, processed in some form, and then you just insert that into the database. So the data is collected as is and stored, just that it may be cleaned up. However, in vector database, I can't do that. The data is sourced, probably cleaned based on the need that arise, and then it is tokenized. That's the most important piece here. It is tokenized, much like how you split a sentence into tokens, into words. So be it your text or image or documents, video, audio, they're tokenized. They're tokenized, vectorized, and then you store it in a database. Okay, so that's that big change that happens when you're working with your vector databases. Okay, because why we're doing all this? We are doing all this. The intent is I should be able to learn through the contents within that unstructured data that you are which unstructured for the system, not for you, but and we want to kind of understand that. So that's that difference it is arising. It manages to capture a lot of relationship as a part of, basically it's a relationship capturing when you're going through the idea of embedding, and then you kind of store that. Okay, so we'll come to understand what actually how the vector database and what itself is a vector database otherwise in the coming slides. Okay, so this idea of vector embedding. So what's vector embedding? Embedding is all about, now if I take it in for the text, text as such, text means, when I say text, it could be documents, or of any PDFs, documents, or general text, including your code. All those fall under the idea of text, which means the data is of sequential nature. It's about sequential nature and represented by some kind of notation. Contrasting that to an image, image is represented by a grid kind of structure where each of that has some intensity. And if you look at, on the other hand, audio, they are also sequence, but that sequences vary as it is kind of going through. So vector embeddings are a way of extracting meanings from, or if I take specifically on the text, now I can't work with a representation within my computer, right? I can't work with the representation. Means when I say I can't work, I can't do a mathematical operation on a text data. It's just a representation. I can only it is just a representation, and all that I can do is just move it around and things, but never a mathematical operation that can. So if I had to do something on a mathematical, then I will have to convert this word into a mathematical representation, or a numerical representation, I should say. And then once a word is represented numerically, then I'm able to kind of create an operation. Likewise, I'm able to do equal numerical representation for an image and for an audio itself. These are, of course, image intensities are there and things like that. But when I look at an image, it's again a representation there, much like text. Just that these representations inside the image, they are of different forms, right? If you look at a mountain, it has its own form. A road has its own form. If it's a human, it has its own form. So, but there are some representations, and trying to get a mathematical or a numerical value for this is what your vector embedding do. And once you do this, you are able to then store it and then do operation on that. Okay, so the intuition behind this, like the most famous example is to, the idea of embedding is to, as I just narrated, is to capture the semantic and contextual relationship between, in case of text, it's text element, so if I look at this verb, this sentence, and there is all that you see is some representation. However, you see that each representation is grouped, and there is a relationship, and that relationship is built through some kind of other structures, which is in this case it's a grammar. Likewise, your images also has some representation, and they may be grouped. If you take a road, you see in the thing, you'll find them, all of them, in one kind of a pixel intensity, right? And if it is probably a human, you may find it in some it's not only the intensity, you'll also find a shape, right? So that's what it's eventually trying to capture, and capturing this is what makes vector database the most. So I should also be adding that it's not only your text and image, or audio, voice that can be represented with. Even your structured data, example like an Excel sheet and or a CSV file, can also be transformed in this way to to a text embedding, and you can actually do an analytics on top of it. That's why you might keep hearing this today's AI is also doing the BI stuff. And the most famous thing, which I'll of course showed in some time, is this this equation of king and queen. So if you look at the words king and queen, although they are not synonyms in any form, they share a similar context, and that context is royalty and monarchy. So this way, I'm able to bring in some relationship, and that relationship can be transformed into a numerical value, and that's what text embedding does. Okay, now this is the transformational idea that is happened with respect to this whole new world of generative AI or large language models. It's just not about large language models. It's about large language models, large vision models, large audio models, and this idea of multimodal models, large multimodal models. So what multimodal model does is it's able to establish, if I look at a figure, just give me a second. I think there is a technical glitch which is preventing showing the slides. I'm just trying to figure that out. Sort out. Yeah, okay. Seems to be there is, hopefully this is resolved now in the way it is. Let me, I think full screen seems to be the issue. Okay, so continuing, the multimodal embedding. Now, what's multimodal embedding? So let's take, if you see a PDF document and there is an image and there is some text around it, and you want to bring in both of this together and have a relation. So in the sense, what the text says, that should have a meaning. It should have something within the image. So if the text says there's a mountain, yes, we should be. So this is the integration of different types of data and bring in a command. So that means now I can then point to the image, get the text out, or point to the text and then get the image out. Right. So this is what your multimodal is kind of doing, and this is what the whole the space of the generative AI is all about. Okay, now again, there are different types of embedding. There is word embedding, which goes at a single level of word. Then there is sentence embedding. The graphs, your social media graphs, they have an embedding of its own. Of course, image. There is image embedding, and there is your audio embeddings as well. So embeddings are of different types, and to do embeddings, you create different algorithms to cater to word, to sentence, to graph, to image. There are various that you would actually go through. Okay, so we talked so much about the embeddings and vector databases, so we understand this idea of what a vector is. So in very simplistic term, vector is just a piece of a sequence of numbers, and this represents a semantic meaning for that particular text or image or whatever that it represents. So if you look at from a now vector can be looked at in different ways. I can look at vector from a geometric perspective. I can look at a vector from an algebraic perspective, and I can look at a vector from an arithmetic perspective. So what we are pretty much used to is the algebraic kind of form, where when I say a vector, it means a set. It's like a list in which a set of numbers are visible. So otherwise, if you're used to in schools, the vector would be more like a graphical representation. You put that in a graph where there is where there is direction and value. Okay, a magnitude, or the other word, which when you contrast that with your scalars. Okay, so that's what is happening otherwise. So how do you build it? So building a vector is about building that particular model. if you are kind of used to embedded, large language models, you would see that um, uh, each of these language models also create their embedding models. And it is through these embedding models, and we have to create different embedding models based on the different kinds of data that it's handling. So text has its own embedding models, image, audio, each one of them have this own, and you also have this multimodal embedding which caters to all of these things together. It could be that image and text together, or image and voice together, or maybe image, text, and voice together. Okay, so this is how it would look like if I create an embedding. And there would be something called an ID, there's a dimension, and there is the actual text. So if I take a word and I make a vector of it, this is how it would look like. And this is what is eventually stored in your database. Okay, so multimodal, now we have seen that I'm able to uh, collocate all the data, the different types of data together, and I'm collocating in such a way that there is a relationship between different data structures together, and it's like having, or to say that I can say that my word is in one column, my image is in one column, or my audio is in one column, and they all represent different yeah, I mean, they are different data structures, but all having the same meaning. Okay, so I can do that with the multimodal stuff. So this is how it would look like, where I mean, different kinds of things all put together. It's just not going to be 2 dimensions. It's going to be hundreds and thousands of dimensions. Once you enter into the world of unstructured data, then the dimensions are like pretty much massive, and we are talking of billions of dimensions. That's how it is. That's how these data are. Okay, so once you make multimodal, what's interesting is if you take here, I can know this image through the audio, or I can know the audio through this image. And I can have these images probably retrieved from images where there are multiple other named entities. Okay, so I can do all of that once I have your the jointly put together all these different data types in the vector database. And this is that famous equation which changed the way that we are looking at the whole AI space, where it says if I were to remove king, it says king minus man plus woman is equal to queen. And this is something that you just cannot do with the word king, man, and woman. So there is something that has gone in the background to create this context. And that what has gone into the background is the conversion of the text into conversion of the text into a numeral, and then once it's in numeral form, I'm able to kind of do any kind of transactions. Okay, now looking at the vector database, so we saw how to we've seen how the process of storing but what itself is core vector database. Now, if you look at it, vector database is basically a list of vectors, and in today's world, these vector databases are stored uh, 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 much like in a database. We call that indexes. So they are stored in indexes, and these indexes are grouped together by some algorithms. As I said, if you have your image and your text, there should be some grouping that is happening. And at the back end, they may be storing it probably like in a relational database, like even an SQLite, or sometimes in a plain text format. When I say plain text format, means like a Parquet file formats. So they are eventually stored in that way. So every vector database has a storage layer, and there's an indexing layer because you have to store your data. There's a querying layer, and there is a similarity computation layer. Similarity is what makes all these data come together and be organized in some form. So that's the whole architecture of your vector database. It's pretty much simple in that context when you contrast that to probably a relational database, where there is, of course, you have your query layer, your storage layer, and the semantic layer as well. But that is pretty much complex because it has to handle various conflicts that may occur within a transaction. Here, the conflicts are less because they are less transactional and more retrieval. So that way the complexity is less. Okay. So the vector storage, as I said, it could be a combination of it. It could be maybe a backend database. It could be a file, or some embedded system. So there are various forms that it can use to store the data. And we look at various forms of storing in the coming up the few slides that we are going to see. Okay, so indexing. Indexing is the process of equivalent to creating a database and then storing the data. So the data is nothing but your list form. Basically, it's a vector. Each word, or if it's a text, each word will be a vector, and it will have a dimension. So it depends on how you kind of architect. So in today's each word would be represented by a dimension of 1,000 numeral. So it can vary on how, and likewise each image will have its own set of things. So it's these dimensions that are that you see together, and then you kind of organize it in an index, which is your equivalent of your database. And there is a whole set of algorithms which help you to kind of do these things. Okay, so different kinds of indexing techniques exist. Now, why indexing is important? Indexing is important just not about storing the data, it's also to organize similar data together, right? So that it becomes easy to retrieve it. And this organization of similar data is massive scale, and we use various kinds of algorithms to help you kind of do it. But you notice there are very familiar algorithms that a lot of these, I'm sure you might have at least worked with few of them, like Elasticsearch and Redis. So they all have their different ways of kind of indexing using various algorithms. Okay, so now what's vector search? So vector search is that next part of after you index, right? And when you're doing the search, it starts with this idea of able to query the whether it is an image or audio and audio stuff, or a text stuff. It could be anything that you want, and you could actually merge them together when you do that particular query. We're otherwise familiar with all these image searches. They were basically early stage technologies that helped come up with to what we are. But today you don't even have to give that image to search, right? I can go and directly search within the image or within an audio clip by just text. So otherwise, if you go to Google search, the search is normally on text that is happening. Now that search goes into an image or an audio or PDF or a Word document, and then it is able to retrieve it. Okay, so this tool called the distance metrics. Okay, now how do you associate relationship between these different tokens, as I described earlier? And if you take a text and if you take a text, if you look at it from a sentence perspective, that sentence is formed by some rules, and when that is formed by some rules, there is an association. It is this embedding based on these algorithms, which is called similarity algorithms, that help you to uh, get that meaning out of it. So those rules the rules on which the text is based is found out by these algorithms called distance metrics. And then the various forms of that, which as you see, and they are used, these same rules or these matrices are used even if it is a text or an image or an audio. Hence, all that I need is I only need by that numeral for each one of them, and then and then you can by that query I'm able to get any of these stuffs. So that's the other side, which is the algorithm that we are talking. Now this algorithm, of course, is a different from the indexing algorithm. Indexing algorithm is all about organizing similarly, but this algorithm that you see, the distance metric, is though I can use it probably for that, but it's not that always used. That there are other ways. This is largely for your query purposes. Okay, so search. There are different forms of search. There is traditional keyword-based search, and there is this modern vector-based search, and you also have the hybrid search. So we look at them at the end. Okay, so you are pretty much familiar, I presume, on this idea called full text search and similarity search. And when you do a full text search, when you need to find some documents that contain a particular word or a phrase, which is deterministic. And when you do similarity search, it's all about probabilistic query there. And then that should help you to kind of get the whole stuff. So, and vector similarity easily allows for cross modal, as I said, could be images, text, everything that put together. Okay, so this idea of semantic and syntactic search. Okay, so the keyword search, or the word which needs exact match and which is otherwise kind of an exact match, I should say. We are pretty much familiar with elastic and all these things, but semantic, the though this is probabilistic, here the search is probabilistic while there is a relationship when I'm trying to do a search. That's your semantic search. And that's what is actually using in the world of AI and ML as such. Okay, so vector database landscape. Now there are different varieties of vector databases. Some are libraries, some are full-fledged databases, some are horizontally scaling, some are vertically scaling, some are NoSQL, some are relational, and we see all these combinations that exist in the vector database space. Okay, so this is largely the space for vector database. You will notice that there is pure vector database that you exist, and then you have your search-based databases, which have also become translated into a vector database. And then what's more interesting is I can have my NoSQL readopted for vector database, and then I can have my SQL databases that are redesigned for vector. And then you have these pure libraries which you can then use and build your own databases. So there is a whole choice that you have, and based on this you can build one of it. And you need to build these vector databases, or eventually what the other term which comes up a lot is vector lake, as much as you have a data lake to organize all kind of data. Okay, so pure vector databases, they have been grounds up built, and they would use one of those algorithms, one for organizing, one for retrieval, and then you kind of build it. And these are built um, from those libraries that I spoke about, but they are built from grounds up. And at the back end, they may be using one of the file formats, they may even use embedded databases like an SQLite or a DuckDB or a Parquet file format to store the actual data. So that's how these pure vector databases are. And then the other form of vector databases are the original search databases, which have now added with the functionality to do the other. So search were syntactic and semantic. So once you make a database semantic for search, that means you made it vector, you vectorized it. So you'll find all of these tools now doing. This is actually probably the most popular form of a vector database that which goes around the world right now in terms of how you store the kind of data. And then you have a vector libraries. It's basically built on these libraries. This whole solution is built, and there are various of these, and one of the most and you'll have you have even Google has its own custom proprietary, I should say, libraries that have been built and kind of utilized. So you can use this and build your own. This is one very popular database library, rather I should say, come from Meta, which is pretty hot, and this is probably the data library going into most of these databases that along with Google's Scan. And then today a lot of NoSQL databases have been redesigned to add your vector capability, and which is pretty much popular. In a very classic case is like a Neo4j, where you use where there's a graph kind of stuffs are used. So you have your Mongos, your Neo4js, all this. Redis itself. Redis is basically both it's an in-memory stuff, and you have many such database NoSQL databases being built. So why a lot of organizations are using these relational or non-relational databases? The search today, and when we saw in the few slides up, the search is hybrid. Okay, so when the search becomes hybrid, I do want my traditional keyword search to my semantic keyword search to build this hybrid solution. Hence, you tend to use these things. And so when I'm using these databases, I'm also using it as a vector data store, and which can scale horizontally, right? And while of course it scales vertically as well. So I already have a solid infrastructure, a stable infrastructure on which I can build, and that's why you've seen organizations doing that. Okay, so if NoSQL was the way, SQL cannot be behind as well, and you would see the Postgres being one of the most one of the most popular databases for building vector stores. So you are using a vector data, you're using Postgres as a vector store, while it serves this purpose of doing a semantic query, and also organizing it internally in semantic, and probably at a higher level a bit with keyword as well. So you're getting the twin advantage of both of these things. So you will see that how this is how you're actually building up the whole vector database. Repurposing, I won't be using word repurposing, but redesigning your NoSQLs and SQLs, open source technologies to build the vector database. It's all about adding those libraries in that. Okay, and then use cases, right? There is, abundance of requirements to use vector. Eventually, this would be one database which would, the original intent of creating a data lake, I think, has been realized when you have vectorized your data. But most important thing is about vectorization, and the quality of vectorization determines the quality of the data that it outputs. Right. So innumerable number of use cases, starting from a recommendation engine to anomaly detection to all kind of processing workflows, you name it, right? There, or I would put it that way: if there is a if there is a database, if there is data generated, I can vectorize it, and once I vectorize it, I can repurpose it for various things that I can use. Okay, so that basically concludes my a little presentation on the whole idea of vector database.
Thank you so much to Mr. Rajeev Chandran for such an engaging and insightful session. I'm sure everyone here has picked up strategies and techniques they can apply immediately. If you guys are interested in learning more about the vector database, do check out our discounted batches of virtual instructor-led trainings on our website, springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable batches, we'd be happy to discuss and schedule private batches for you. If you don't have time to join live online, then do try out our affordable self-paced courses. For more information, do write to us at training@springpeople.com or call our number displayed on the current slide. Thank you, everyone. We appreciate you being here. We shall be sending out the webinar recording to all your participants soon. I request you to kindly provide feedback before signing off, which will really help us improve the quality of our future events. Thanks again for joining us today. Signing off on behalf of Team Spring People. Hope to see you again for our next expert webinar. Take care. Bye.